So let us now proceed with the discussion of the problems about our strength of material. So kagabi, nakapag-solve tayo ng dalawang problem. So let us proceed with the solving nung dalawa pang susunod na problems. Okay? Now let us show muna yung mga gagamitin natin. Okay? The problem goes like this. So let us proceed. A 2-meter long aluminum bar with modulus of elasticity 70 GPa, gigapascals, okay, that is in SI units, is subjected to a tensile stress of 175 megapascals. Find the elongation. Now, ano ba yung elongation? Elongation is the state where your material tends to deform, okay? Yan, ibig sabihin yan, that is the deformation. Elongation or deformation. Now, pag nag-deform yan, ibig sabihin there's a change in the length of the material due to the loading. Now, meron tayong mga binigay dito na parameters, okay? So, this is the length of the bar. Now, this is an aluminum bar. Ibig sabihin, kailangan kabisado mo yung value. But in this case, ibinigay naman niya yung modulus of elasticity or the E. So, given na yan, elasticity o the E. Okay. Is subjected to a tensile stress. So, that is stress. And you're asked to find the elongation. Now, we will go with the formula na ito. Diba? Nakangiwi. Ibig sabihin, that is Pauline Luna ayaw kay Andrew E. Pauline Luna ayaw kay Andrew E. But, you are not given any load and any cross-sectional area. Okay? As we can recall, stress is given by the formula P over A. And we are given stress, okay? So, we can substitute na yung stress pagdating dito sa dalawang to. Okay? So, now we will have another derived formula which is stress multiplied by L over E. SLE. Okay? So, may na-derive na naman tayo. Anong hinahanap natin dyan? This is the deformation. Okay? Wala naman sinabi kung cm or in millimeter. But, I prefer mas maganda millimeter. Okay? So, let us now go with solving. So, S, ano ba yung stress na ibinigay dyan? That is 175. 175. So, MPa, kailangan convert mo na agad siya into Newton per millimeter squared para hindi ka na mahirapan. Okay? 1 MPa is equal to 1 Newton per millimeter squared. Okay? And then you multiply it with the length, 2 meters. So, i-convert na agad natin, i-multiply natin ng 1,000. That is 2,000 millimeter. Okay? Para hindi na tumatagal yung calculation natin. mm. Okay. And then we will divide it with the elasticity. The elasticity is given 70 GPa. Okay? 70 GPa. So, you will multiply that with 1,000 para maging MPa. Okay? 70,000 Newton per millimeter squared. Now, we can cancel the same units. Okay? And we will arrive with mm. So, let us calculate. 175. This is very basic calculation lang. Okay? All you have to memorize is the formula. Kaya, madali siyang i-solve. Okay? Ganun lang naman sa machine design. Mahirap dito kapag wala kang formula. So, now, the deformation due to the stress is 5 mm. Liit lang ng deformation. Ibig sabihin, malaki yung cross-sectional area ng bar. Okay? Now, in case of strength of materials, hanggang sa machine design, we'll just revolve around the different formula. Some of them empirical, some of them can be derived. Okay? Using the simplest formula you'll ever learn. Kaya marunong ka dapat mag-algebra, marunong ka mag-substitution, marunong ka mag-lipat-lipat. Okay? Mag-inversing, yan. Okay? And then let's proceed with another problem. Now, the problem goes like this. A 600 millimeter tall tin plate is placed in tension by a 5,000 kilonewton shear force. Okay? Let us highlight the key factors. So that is 600 millimeter tall. That is the height of the thin plate. And then 5,000 kilonewton will be the shear force. Ang tinatanong, what is the height in horizontal or the y direction of the plate while the tension is applied? Okay? The modulus of elasticity is 200 GPa and the Poisson's ratio is 0.3. Assume that the load is distributed uniformly across the plate and the yield strength is not exceeded. Ano ba yung hinahanap dyan? Okay? So you will revolve around yung Poisson ratio, okay? And then, meron tayong binigay dyan na E, pero binigay dito yung iyong material. Okay? We will assume this is steel plate. Okay? Pakita muna natin yung kanyang diagram. Okay? Ganito ka thick yung iyong steel plate and then this is the loading. Okay? 5,000 and then ito yung magiging height niya. Kapag kinuha mo yung cross-section. Now, paano natin siya gagawin? Kailangan natin yung Poisson ratio. Okay? Kailangan natin i-note muna yung lahat ng given. So, this is the F. Okay? Yung Poisson, that is mu, or V. V yung iba dyan. Ako, mu yung ginagawa ko. This is E. And how will you solve it? Okay? We take note that the Poisson ratio is the strain at lateral or at X over strain at longitudinal. That is Y. Hindi, baliktad ata. Lateral is Y. Longitudinal is X. Longitude. Longitude ito. Along the length. Yung Y along the height. So that is negative. That is your Poisson ratio. Now, itong strain na binigay sa'yo is the strain at longitudinal. Okay? You are given a strain in longitudinal or along the length. So that is that is the stress over elongation. Tandaan nyo yung strain equal to stress times elongation or you will denote si C. Diba? C. Ayan C. Binigay natin yung kagabi. Okay? Tingnan natin dito sa notes natin. Discussion, okay? Yeah. Not that one. Hanapin natin. Ayan the Poisson ratio is equal to the lateral divided by longitudinal strain. Now, kapag base sa Hooke's law, okay, you are given a stress and then modulus of elasticity and then the normal strain. Now, yun yung ating gagamiting equation. Okay, we are given ng force. Meron tayong area makukuha. But we have to solve for the area. That is the cross-sectional area. Okay? For the area, what is the area? Okay? The area of your material is yung length times width. Now, the length is 600 mm times yung thickness niya 25 mm. We will solve. Calculate natin. 600 times 25. The area will be 15,000 millimeters squared. 15,000 millimeters squared. Now you are asked to find the longitudinal strain. Okay? Longitudinal strain. Okay. Meron kang stress, where stress is F over A and E. So, we will derive another formula. So, strain will be equal to your force over area times E. Now, you have F, that is 5,000 kilonewtons. Gawin na lang natin newtons. 5,000 times 1,000 newtons. Okay? divide by 15,000 millimeters squared. I-multiply natin ang E. Ano ba yung given na E dyan? That is 200 GPa. So that is 200,000 MPa. 200,000 Newton per millimeter squared. Okay. Now, cancel natin yung same units since ang strain is non-unit. Okay? What will be our answer? Okay? Okay? That is 5,000 times 1,000 divided by 15,000 times 200,000. So, okay, that is 1 over 600 ang ating longitudinal strain. 1 over 600. Huwag muna natin siyang i-simplify. Okay? So, let us store this value in A. And we will solve now for the value of Y. Kasi given naman sa yung Poisson ratio. Ito wala to. Wait, tanggalin. So, tanggalin natin ito para hindi siya natin dito. Okay? So, solve na natin si Y. Okay? Si lateral. Okay? Nahanap natin si lateral. Okay? The lateral strain now is equal to yung iyong Poisson ratio times the longitudinal strain. So, the Poisson ratio given is 0.3. 0.3 times 1 over 600. Now, what will be your lateral strain? Okay, that will be 0.3 triple A. Okay, 1 over 2,000. Yung lateral strain. Ano pang gagawin natin dyan? Okay? Meron kang tingnan natin ano lumabas. 0.5. Okay, so ito yung naging strain sa lateral mo. Okay? And that is pwede nating gawin to find Y. Okay? Y is, tignan nyo, saan ba nagkaroon ng strain? Diba? Ang lateral strain mo is in the entire length lang nito. Yung pataas. Okay? So, you have a height na ganito and then meron kang naging strain. Okay? That is stress divided by the elasticity. Okay? Now, you will have the total height or Ly minus mo yung iyong lateral strain. Okay? So, that is 600 mm. Pwede kasing maging ganito to eh. Mm divided by mm ang Poisson ratio. Mm divided by mm. Yan. So, 600 minus 0.0. 0, 0, 5,000 kilonewton. Tama na, 5,000 times 1,000. So, 1 over 6, 1.66. Yung recall A, that is 1.67, tama naman. So, 5 times 10 to the negative 4, 0.05. Okay? 0.0005 mm. So, this will be 599.0005 ang iyong Y. Okay? That is for discussion